All right, so let's work on question number 4 of recitation 4. So for this question, we are asked, where would a clock be after so many hours? So the question is, what time does a 12-hour clock read after so many hours? So for 4a, it asks, if it starts at 11, what does it read after 80 hours? Right? So one way to think about this graphically is to think of a clock, right, with the 12 hours. And if you start at 11, right, and you go around once, after 12 hours, you're going to end up again at 11. Right? So after 12 hours, you end up at 11, and you go again 12 hours. So after 24 hours, you end up again at 11. If you do this repeatedly, after 36 hours, after 48 hours, after 60 hours, so after 72 hours, almost 80 hours, right? After 72 hours, you end up again at 11. So after 72 hours, you're now here at 11. And you still have 8 hours to go, right, to reach 80. So where would you be, after 80 hours, to reach your 80, after 8 hours, to reach your 80 hours. So you'd be at 1, 2, 3, 4, 5, 6, 7, 8. You end up at 7, right? So notice that the clue here is that you reach 72 hours, right, after having gone around the clock several times in 12-hour intervals, right? And you still have 8 hours to go. So 8 hours to go. So what this tells you is that, basically what we found out is, that we can divide 80 into several equal parts, and there's still a remainder there, right? So how can we use modules to do the same thing? Well, if you have 80, right, and we want to know how many times can we evenly divide this into 12 equal parts, right? Then we can, divide it by 12, and then ask, how many more, what is the remainder of having divided this evenly, right? And this gives you 8. And this is the same 8 that we got here graphically, right? And once you have 8, you can just, do some arithmetic, time arithmetic, and you have time 11 plus 8 hours, right? It gives you that, it takes you to 7 p.m. All right, so for 4b, we're asked that what would the clock read, right, 40 hours before it reaches 12. Again, graphically, we can think about it this way, right? You have a clock, a 12-hour clock, right? If you start, if you are going to end up at 12, right? Where would you have been before, 40 hours before that, right? So again, you can go around backwards 40 hours in time, right? So go around once 12 hours, and then you go again 24 hours, and then again 36 hours. And so we almost reach 40 hours backwards, right? That means that when you reach this 12, you still have 4 to go, right? We still have 4 to go, right? That we're going backwards, 1, 2, 3, 4. Right? That puts us at 8 p.m. Okay. Right. Again, we like to be able to do this mathematically using modules, and so we can represent this. We can come up with the same 4 by saying that, if you take those 40 hours, right, and you want to evenly divide them into 12, right, you end up that you can't divide them evenly. You're gonna give you the nearest thing you can do is come up with 36, and then you're gonna still have 4 left over, or your remainder is 4, right? And then from there you just do some time arithmetic where you are at 12 p.m., right? And then if you subtract 4 hours, you end up with 8 p.m.